When we look at reactions, sometimes when we analyze the reaction, realize that, hey, we had a whole bunch of ions and we had a whole bunch of other ions, and we mixed them together and absolutely nothing happened. Other times, when we mix all of that together, we go, oh, hey, we actually did form a product. Maybe it's a gas, maybe it's a precipitate, maybe it's a slightly ionizable substance. Okay, and when we form those products, we can take a look at our traditional molecular equation. And then we can start breaking it down into our total and our net ionic equations. And we can analyze what reacted and what just hung around and did nothing. So, and when we do that, we can also figure out at the end of our reaction how much of each ion is left in that solution. And that's where we get into what we call solution inventory. So let's take a look. All right, so here I have a picture. From this picture, can we tell that a reaction occurred? Absolutely, because we went from a clear, colorless liquid and a clear yellow liquid to something that had a orange precipitate at the bottom. So we had, according to this picture, some silver nitrate and some sodium chromate. So we know again that soluble ionic substances dissociate into solution. And so I have, a container of ions and I have another container of ions and I dump them together. The formation of the precipitate tells me that something did indeed form. So when I look at this, if I look at my silver nitrate, plus my sodium chromate, okay, we can potentially form two different products. Our potential products are going to be sodium nitrate and silver chromate. Okay, and so what do we need to remember in order to figure out what precipitated, if anything? Our solubility rules. And when we look at our solubility rules, we realize that the sodium nitrate is soluble and the silver chromate is our precipitate. Okay, this absolutely is something that we hammer in prep chem. So if you're not remembering this stuff, you may need to go back to your prep chem notes, or you can find the videos I have for the prep class here on my YouTube channel. I think this particular stuff is covered in the 120/152 chapter 9 videos, I believe is the right chapter for these. Okay. And then once we have this, then obviously we go forth and we can balance our equation, and then we can break it down and write those total and net ionic equations, which you can see right here. So again, the total ionic equation carries everything, and then that net ionic equation only looks at what actually reacted. Okay, so that should be a review. So now we're going to put this together in a bigger picture. So I've got this crazy problem here. We've got some barium nitrate and some potassium sulfate. We want to write all three types of equations. Then we need to figure out the mass of any precipitate that was formed. And then we're going to do the solution inventory. Okay, so we've got a few things that are happening here. Okay, so barium nitrate, potassium sulfate. So I've got a few blank slides coming up that we're going to put this all together. And I'm mixing an amount of component A and an amount of component B, which means that this is going to be what type of a problem? A limiting reagent problem. So we'll do an ice table as well. Okay, let's take a look. All right, so we've got barium nitrate and potassium sulfate. Okay. All right, so what are our two potential products? Well, we can get potassium nitrate and barium sulfate. Okay, and so then we turn to those handy dandy solubility rules and we figure out that the barium sulfate is a solid precipitate because it's insoluble, and the potassium nitrate is indeed in an aqueous solution as ions. Okay, so now before we can do anything else, we need to do what? We need to balance. All right, and so we will balance it with that 2 there. Okay, now that we have our conventional equation written, now we can write our total ionic equation. Okay, so we've got 1 barium ion. We have 2 nitrate ions. We have 2 potassium ions. We have 1 sulfate ion. Okay, so there's my reactants. Now for my products, I have 2 potassium nitrates, so I still have 2 potassium ions. I have 2 nitrate ions. And then my barium sulfate stays together as a solid. It does not dissociate because it's insoluble. Okay, now what do we do next? We analyze it for what stays the same on both sides and what changes on both sides. Now I like to, instead of cancel out what shows on both sides, for this I underline what I keep. Okay, I do this. This is the way I teach it because when I'm grading these and I have to grade the conventional, the total ionic, and the net ionic equations, if there's a bunch of stuff crossed out, it makes it a little harder to grade. Okay, so when I analyze this, I don't have any barium ions on my product side. I don't have sulfate ions on my product side, and I don't have barium sulfate solid on my reactant side. But I do have 2 potassium ions, and I do have 2 nitrate ions. So those are my spectators. They started off as ions. They finished off as ions. They didn't really do anything. They just kind of hung out. Okay, so now I can write my net ionic equation, which is just what reacted. So there's my barium ion, and there's my sulfate ion, giving me my barium sulfate solid. Okay? All right, so now the next part of our problem asks us to figure out the mass of that barium sulfate. And because I had amounts of both, we have to solve a limiting reagent problem. All right, so here I've got my ice table all ready to go. So we're going to look at our barium nitrate. We're going to look at our potassium sulfate, our barium sulfate, and the potassium nitrate there. Okay? All right, so we have our starting amount, something will change, and then our reaction will end. All right, so first we need to figure out what goes into that table. Well, I know from the beginning that I'm not going to have any of this or this because those are my products. I have minus x, plus x, and plus 2x. I can do that part without doing any math at all. Now, we were given volumes and concentrations for our 2 reactants, and so we need to convert that to moles to put that into our table. So we have our barium nitrate, and we have our potassium sulfate. Okay, so we're going to take 581 liters, 0.342 moles per liter, and we're going to get 0.1987 moles of barium nitrate, and then our potassium sulfate, we have 0.264 liters, 0.631 moles per liter, giving us 0.1666 moles. Okay, so now I can put those in. 0.1987, 0.1666. All right, now I have to figure out what x is. All right, so I get x is equal to 0.1987. X is equal to 0.1666. These are nice because it's just one x. I don't have to do any math here. What's the smaller x? The 0.1666. All right, so I'm going to put an asterisk next to it. That is our x. So we will lose 0.1666. We will lose 0.1666. We will gain 0.1666. and we will gain 2 times 0.1666. Okay, and so at the end we have 0.321 moles of our barium nitrate left. We have no potassium sulfate. We've made 0.1666 moles of barium sulfate, and we've made 0.3332 moles of our potassium nitrate. Okay? All right, we want to know the mass of the barium sulfate. All right, so we're going to take our 0.1666 moles, and we have 233.4 grams of barium sulfate in 1 mole. And that's going to give us 38.88. If we go back to our original problem, we have 3 significant figures. So we have 38.9 grams of barium sulfate that are forming. Okay, now the last thing it asks us is to do what is called a solution inventory. So we're going to take a look at what was left in solution at the end of our reaction. Okay, so solution inventory, we want the molarity we want molarity of each ion at end of reaction. Okay, so first we need the total volume. All right, we mixed 581 milliliters of our barium nitrate solution with 264 milliliters of our potassium sulfate solution, which gave us 845 milliliters. We're doing molarity, so we need liters, so we got 0.845 liters of solution total. Okay, so let's take a look. Our barium. Okay, so for our barium precipitated. Okay, it was not part of the limiting reagent. Remember, we had potassium sulfate, so our sulfate ion was limiting. So it's precipitated, it was not limiting. So therefore, I'm going to use the amount left at end of reaction. Okay, so I had 0.0321 moles of barium nitrate left at the end of the reaction. I have 1 mole of barium for every 1 mole. And then I need moles per liter, so I'll do a unitless 1 over my 0.845 liters, and I'm going to get 0.0380 molar barium. Okay. All right, now my nitrate and my potassium. Okay, these guys were spectators. They did nothing, okay? They started off as ions, they ended as ions. The amount we started with is the amount that we end with. The concentration is different though because we have a different solution volume, okay? So we're gonna use the moles at the start because the moles we started with is equal to the moles we ended with because they did not react. Okay, so for the nitrate, we had 0.1987 moles of our barium nitrate that we started with. We have 2 moles of nitrate for every 1 mole. Okay, final solution is the same for everything. So we have I accidentally hit the purple. We have 0.845 liters, and so we end up with 0.470 molar nitrate ion. Okay, potassium, similar thing. We have 0.1666 moles of our potassium sulfate. We have 2 moles potassium in every 1 mole. And we have 0.845 liters. So we're going to get 0.394 molar potassium. Okay? All right, and then sulfate. This one's easy. Sulfate precipitated. And it was limiting. Therefore, none left. So we get 0 molar. This is really, there we go. Okay, and so that is how we do solution inventory.